Let's look at the power rule for multiplication. Now, the power rule is different from the product rule. Remember that the product rule says that if we have two exponential expressions, let's say x to the power of a times another exponential expression with the same base, x to the power of b, this will result in x raised to the power of a plus b, where a and b can be any numbers. Now, the power rule tells us that if we raise an exponential expression to a power, so for example, if we have 2 to the third power and we're raising this to the fourth power, then that is going to equal 2 cubed times 2 cubed times 2 cubed times 2 cubed. Now, using the product rule that we have up here, we can say that because these all have the same bases, they all have a base of 2, this is going to equal 2 to the power of 3 plus 3 plus 3 plus 3, which indeed is going to equal 2 to the power of 12. Now, if we compare our answer here with our original question, how did you get 12 from 3 and 4, looking at the exponents? And you'll see that 3 times 4 equals 12. Now we can check if this is true for other expressions. So let's say we have 5 squared, and we're raising that to the third power. That is going to equal 5 squared times 5 squared times 5 squared. And using the product rule, this is going to equal 5 to the power of 2 plus 2 plus 2, which equals 5 to the 6th power. And again, the exponents that were in our question were being multiplied to form the exponent in our answer. And this is true for any terms as long as they are being raised to a power. So for example, the general rule then would be x to the power of a. If this is being raised to the power of b, this is going to equal x to the power of a times b. So look at the difference between this rule, which is the power rule, and the product rule. In the product rule, we are multiplying two terms that have the same base. For the power rule, we are raising an exponential expression to a power. And when we do that, we are multiplying the two powers together.